Welcome to this Mathcast. In this episode, we're going to be looking at how to calculate probabilities that involve unions. Let me just remind you of the addition rule. The addition rule says that if you're asked to find the probability of the union of two events, then you take the probability of the first, add to that the probability of the second, and subtract off the probability of their intersection or their overlap. So this is called the addition rule. It's the rule that lets us calculate unions. So I want to look at two examples with you. We'll start off here with this first example. And this first example is going to involve some playing cards. And what I want to do is look at, you draw a single card. From a 52 card deck. What I want to know is, what is the probability that that card is a queen or a heart? Okay, so the idea here is we need to identify what the events of interest are. In this case, the events of interest are queens and hearts. So I'll start off by letting the set A be the set that, or be the event that represents drawing a queen. And we'll let the set B represent drawing a heart. If you look at our addition rule, in order to calculate the probability of A or B, the or coming from the union symbol here, then I need to calculate the probability of A, the probability of B, and the probability of their intersection. So I'll start off first with A. The probability of A is the probability of drawing a queen. Well, if you think about it, there's 52 cards in the deck and 4 of them are queens, so it's 4 out of 52, which reduces to 1 out of 13. Next up is the probability of drawing a heart, and there are 13 hearts in the deck, and so the probability there is 13 out of 52, which reduces to 1 out of 4. Alright, the last thing we need to do is we need to look at the overlap being A intersect B. If I had to describe this set, well, it's the set that involves both queens and hearts. Well, there's only one thing that is in that set, and it's queen of hearts. So I'll do my best to represent that here. Drawing a queen of hearts in this case is the only thing that fits into both A and B. So the probability of A and B is that one single card out of 52. There's not a lot of chances of you drawing the queen of hearts. If we then take everything together and you're asked to find the probability of queen or a heart, well, I'm just simply rewriting the addition rule here because that's what it is you should be doing, is the addition rule. So the probability of A is 4 out of 52. Probability of B is 13 out of 52. Probability of the intersection is 1 out of 52. And since I use the 52 here as the common denominator, add them all up, it looks like you get 16 out of 52, which reduces to 4 out of 13. So that's our first example that I want to look at with you. Let's look at another one. It's a little bit different here. The second example, the experiment that I want to do is I just want us to choose a day of the week at random. And what I'm interested in is what is the probability that the day chosen is Friday or Saturday. Now, if you look at what we have here, we have two events of interest, Friday, Saturday. So event A would be Friday is chosen. Event B would be Saturday is chosen. And we could quickly do the probabilities on those. The probability of A is clearly 1 out of 7. And the probability of B is also 1 out of 7. Alright, what about A and B? Addition rule says we're going to have to calculate that. A and B would be both Friday and Saturday. Well, the probability if you're picking one day out of the week of getting both Friday and Saturday is non-existent. That's not possible. You can get either one of them, but you can't get both of them on a single choice. So that probability is 0. And I'm just using 0 out of 7 here because I want a common denominator. Well, if you take this and you go to find the probability of A or B, you first start with the probability of A, add to that the probability of B, and then subtract off the probability of both. Well, this is pretty straightforward, and it's exactly what you would expect the answer to be. It is 2 out of 7. Friday, Saturday make up 2 out of the 7 weeks, so you have a 2 out of 7 chance. That seems very straightforward, very realistic. What I want you to understand here is that we had no intersection. Anytime that's the case, the events that you're looking at are mutually exclusive. And if the events you're working with are mutually exclusive, then the probability of A or B happening is just the probability of A plus the probability of B. In other words, there's no reason to subtract off the overlap because there won't be one. So we really have two addition rule formulas here. We have the formula in case of the events being mutually exclusive, and then we also have the formula that we started with, and that is the formula that we have just in general. You can always use the first addition rule on any problem, but sometimes it's good to know before you're heading into the problem whether the events are mutually exclusive, so you can rule out the step here that we did in this last example. You can rule out this step right here of having to calculate the intersection. That wouldn't be necessary in that case. Alright, I hope this has sort of opened your eyes up to how to calculate probabilities involving unions. It's going to be a topic that we'll use at several different places throughout the rest of the probability section. Thank you for watching.